All right, so I'm going to continue on. We are doing the mass of 5 moles. So just like before, I'm going to write the given. If I have a pen, I'm going to write the given. Okay, but I don't want the given. So I'm going to take the units and put it down here. Now it's asking me for mass. Well, mass is grams. So now I know my ratio. I'm going from how many moles to how many grams. Excuse me. It's always 1 mole. Okay, and these ratios right now, it's always 1 mole. Because my periodic table, where I get the grams from, only tells me my values for 1 mole. Now molar mass, we have to figure out what the molar mass is of this stuff. So I have calcium. I have 1 calcium. And I have 2 chlorines. I'm going to go to my periodic table. I'm going to look up calcium. It's in grams. I'm going to round it to tenths. Now chlorine, I'm going to look up chlorine. And then I'm going to sum up these guys. So 111.1 grams. That's my molar mass. Okay, I'm going to cross off the moles. And, oh, I can do that one in my head. That's my answer. All right, why don't you guys work this one out, similar to the last problem. Go ahead and pause the video. When everyone's done, start it again. All right, so I'm going to start by writing the given. 3 moles of CO2. I don't want moles, so I'm going to put them down here to cancel them out. I do want mass. The question says, what is the mass? Well, mass is grams. Now to figure out how many grams to moles, well, it's always 1 mole, because the periodic table is always 1 mole. I'm going to go over here now. I have 1 carbon here, and I have 2 oxygens. I look up on the periodic table. I look up carbon on the periodic table, and there's 12. And I look up oxygen on the periodic table, and it's 16. And I'm going to multiply them across. And add down. Put that number up there, 44 grams. It's always 1 mole, and it's a number that's reasonable, 44 grams. Okay, and if I do 3 times 44, I get 132 grams. I want to cross these units off as I go. All right, my third type of conversion is volume. So again, I'm going to start by writing the given. I don't want the units of moles, so I'm going to put it down here. I'm looking for volume. Volume is how much space something takes up, and we like to measure that in liters. Now, how do I know the moles to liters? Well, I have it memorized. It's always 1 mole. All of these fractions today have been 1 mole. And my 22.4, that's just something I got to memorize. And I multiply that, 22.4 times 5, and I get 112 liters. And again, my answer, volume, so I know I did something right. Alright, it's time for you guys to work out this problem. Pause the video, restart it when everyone's done. Alright, I'm going to write the given, 7 moles. I don't want the moles, so I put them down there. I'm looking for volume. Volume is measured in liters. It's always 1 mole. All of these fractions today, it's always 1 mole. And it's always 22.4 liters. That's a constant. You have to memorize it. Okay, and if we do 22.4 times 7, we get 156.8 liters. Alright, now something new today. That's all been reviewed. And remember, everything I said, every ratio we used is 1 mole. 1 mole to 22.4 liters, 1 mole to a certain amount of grams, and 1 mole to 6.02 times 10 to the 23rd things. Those are all fractions you should know and be familiar with. Memorize them if need be. But now today we're going to have something different, a mole to mole ratio. This is the one time when everything is not 1 mole. This is the only time where you're not going to use 1 mole. Alright, let's look at an equation. This is ammonia gas. Now, we remember on the writing these equations, we have the subscripts here, and we have the coefficients. The coefficients are obviously the big number in front. Now, I'm just going to bracket these guys. I like to bracket them. Your book doesn't do this, but I think it helps to emphasize everything in there is a unit. NH3 is a unit. They're all connected. H2, those are 2 atoms connected, and N2, these are 2 atoms connected. Okay, so this tells me what it's made out of. My 3 in front, my coefficient is difference. That tells me how many. So I have 3 H2s. So if I was to draw this, there's N2. They're connected, covalent bonds. There's H2, and it says I have 3 of them. And then NH3 over here, they're all connected. Whoops. Alright, so that's what this means. And that tells me I am missing the coefficient. And I knew that because I have 6 hydrogens going in and only 3 coming out. So I need another NH3. Alright, so that's what I got. 1 of these goes in, 3 of these go in, they all jumble up and get mixed up, and out comes these 2 ammonia molecules. Alright, so what does that mean? A mole-to-mole ratio is a quantity of how many of each things I have. So we could rewrite this as 1 mole of nitrogen plus 3 moles of hydrogen are going to produce 2 moles of NH3. Okay, all I've done is add the word mole in front of each of these. So with that, I have a ratio. Well, what's my ratio of moles of nitrogen to moles of hydrogen? I'm just writing this mathematically as a fraction. Well, this tells me for every 1 mole of nitrogen, I need 3 moles of hydrogen. Now, I can do that ratio for any of these guys. Let's say I want to know my moles of NH3. Whoops. I want to know what ratio of moles of NH3 do I get for every mole of H2. It's a mole-to-mole ratio. Well, I just take the numbers from here. 2 moles of NH3 for every 3 moles of H2. It's a 2 to 3 ratio. No different than a recipe if I'm cooking something. If I'm cooking a bacon burger, I want 1 hamburger for every 6 slices of bacon. It's a 6 to 1 ratio. If I'm cooking some ammonia, I need 3 moles of H2 for every 1 mole of nitrogen. Okay, that's my recipe. So this is called a mole ratio. This is the only time it does not have to be 1 mole. Sometimes it can be. All we do is take our number from here. 1, 3, 2. And we could even do this. Whoops. Okay, so these are my magic coefficients. Alright, so those are mole to mole ratios, and those are going to be very important for tomorrow's lesson. And again, it's always 1 mole, with the exception of these new mole ratios. Alright, so what I want you to do is, given this equation, write all of the possible mole ratios. And there is 6 of them. You could write 3. Just go ahead and write 3. And then we'll flip them upside down. Go ahead and pause it and do that. Alright, so I could read this just like, need my pen again. I could say this is 4 moles of aluminum plus 3 moles of oxygen. Okay, that's my recipe. If I want to make some aluminum oxide, I need 4 moles for every 3 moles. 4 to 3 ratio. And all I'm doing again is writing the word mole in front of here to figure out what I got. Alright, so if I make a ratio now, let's see, if I want moles of aluminum, I want to know what ratio in this recipe of moles of aluminum to moles of oxygen. I just take the coefficient. 4 aluminums for every 3 oxygens. Okay, that's 1 mole ratio. Let's see, I could also go moles of aluminum to moles of aluminum oxide. So this tells me for every 4 moles of this, I get 2 moles of that. Alright, so I said there's three ratios. My other one, let's see, we don't have moles of oxygen per moles of aluminum oxide. And I just take the coefficients. Oxygen, 3. Aluminum oxide, 2. Alright, I also said there are 6 ratios. The other 3 ratios are just these flipped upside down. Okay, so that would give me my 6 ratios. All I'm doing is I'm just taking one thing and putting it over another. Alright, that's mole ratios.